In this session at GroupBy, Erik Darling is going to be talking about how to improve select star queries. So take it away, Erik.
All right. Now, I wrote this deck because you're all horrible people and you all do this to your servers all the time, or you work with developers who are horrible people and do this stuff all the time. Now, let me just make sure. Is this thing on? Am I working here? All right. Ooh, nope, my clicker. My clicker is deceiving me. All right, never mind. So the first thing I want to mention here is that there is absolutely no dynamic SQL involved in this. I'm not going to sit there and tell you just let your users choose a list of columns because that's nonsense. Never give users choices. The more choices you give users, the more pain you're going to feel, the worse things are going to get. Limit your users to nothing. They get nothing. You get what I tell you you can have users. They're awful. Now, what we're going to cover is sort of some typical scenarios for why select star queries tend to happen. When select star doesn't really make me that angry. When select star does kind of make me that angry. How select star makes indexing hard, and then finally how to make select star sort of less bad, how to sort of fix select star queries on your server. So why would you do that? Why would you ever do select star? Why would you ever write a query and put it in production? It doesn't have to be select star. It can just be like every column listed out. It doesn't have to be. It can just be a wide list of columns. But why would you do that? Like sometimes it's really innocent, right? It's just like you don't know if you need all these columns. You might need some later. You just want to get them to be safe. Just like I'm just going to get them all now and then later on I'll figure out what I actually need. I'll like do some work later and narrow this down. Sometimes it's just silly. Where like you'll have a project manager who just keeps asking you for more data and you just start making stuff up. I've totally done this where a project manager is like, but the report doesn't have anything interesting in it. I'm like, well, these are all the people over 65 who worship Satan and have killed a cat. Like this is the people you want to target for this new bank credit card, right? These are the people you want. Other times it's just pure awful laziness. Now, what I run into consulting more than anything is where someone has written their app and they have just written all like the sort of like cursory stuff to get data from tables, but they never picked columns from those tables. So every single one of their entity framework queries is just the equivalent of select star, but it's like select extent one, every column in the table where left join something nonsense, garbage. Don't do this. Richie wrote a great post, Richie, about how to select specific columns in any framework after like weeks of me bothering him to do it because I always wanted to have something to point to when I run into these people who are like, no, I don't know how to pick columns. I didn't know I could do it. Thank you, Richie. You finally contributed something. And of course, I will run into some people who will tell me that they didn't know it was bad to just select every single column in the table. Just like, why does it matter? I have all this data. Why does it matter how much of it I want? Well, if you go to the gym and you put increasingly heavier things on a bar, that bar gets harder and harder to pick up. If you just want an int column, that's like an empty bar. That's nothing. That's 4 bytes a day. SQL doesn't care. You start tacking some other columns on, all of a sudden you have more and more stuff. That bar gets heavier and heavier. All of a sudden you don't know what to do. SQL Server has the same problem. The more you want to get from SQL Server, the more work it has to do. Now, if I asked you to leave your house in the morning, right? If I selected you from house into car, and there was just you by yourself, you didn't have anything else with you, that would be real easy. If all of a sudden I was like, okay, well, let's take you and your living room couch and put that in the car, and now let's take the dining room table, and now let's take the bed from upstairs, and now let's take a couple of dressers. All of a sudden, the more things I want to get out of your house and into that car, the more work you have to do. SQL Server has to do the same thing. And when you go to deal with it, you're left with these awful, awful, grim choices. You can make a really wide non-clustered index, right? Just like include every column in the table, maybe have a couple of key columns just for good measure. You could get really paranoid and maybe rearrange your existing clustered index. So like maybe I chose poorly. Maybe I just used the wrong column. Maybe I need like 6 columns in my clustered index. Everyone's just using these columns. I don't know what to do because they're pilling all this stuff out. Or you could just create like a narrow non-clustered index with just some key columns, and like maybe you'd get away with it to a certain point where like the optimizer would use it like oh, we'll use it, but not like reliably. You know, it would get some use, but not all the use that you want. The optimizer would just be like, well, it's good for this one, but not for this one, so I'm just gonna sometimes use it, sometimes not. And that doesn't help either because when the sometimes not comes along, your query slows down to like a crawl and people are calling you and they're angry and you're just trying to drink by yourself under your desk. This is not the moment of Zen that you wanted. I don't like any of those, and that's why I wrote this deck, because I want to give you a better option for dealing with these things. So when is it not that bad? Well, if you're only grabbing one row, like if you literally, like you were doing a single row lookup on the primary key, it's really not that bad. Now, I'm not saying it's good, because you're still reading a lot of potentially unused columns. And if you have any like long data or max types in there, you could be reading a lot of extra junk. So let's go look at what happens. Oh, this is going to happen all day, where I go to do this and I just wanted to do that. So let's go look at what happens when you try to read a whole mess of lob data from a query, right? So let's just make sure I have this set on here. Y'all can see SSMS, cool, right? Thumbs up. All right. So if I just, now this is the primary key of the post table. And there is nothing else going on in here, right? So I'm selecting one row. I put the select top one in there because I want you to be extra confident that only one row has come out of this. But the ID column in the post table is just the ID is the primary key. So this is just going to be one row. How many reads do you think this is going to do to get one row from posts? Go ahead and pick. 4. Shy. It's an anonymous poll, man. You can just click whatever you want. You can make a weird D equal sign thing if you want. All right, never mind. Let's move on. So if I go and I select one row from this table and I get all this stuff out, and it's an apologies because I'm quite new to XSLT2, so don't worry about that. We do 4 logical reads, but we also do 82 lob logical reads. Isn't that a bummer? 82 to get one row. We read 82 pages to get one row out. Doesn't that suck? Like why would you do that? Now, if we go and we run almost that same query, but we're getting one row again, but we're going to skip getting the body column. The body column is the only column that we're not going to pull out of there. How many reads do you think we're going to do here? Good news. It's only 4. So just to get one row, as soon as we stop getting that embarcar max column from the post table, all of a sudden we're down to just 4 reads. So that's pretty nice. I'm not going to do a big demo about off-row data because DBCC page and ender is boring as hell, and I kind of respect your time a little bit more than that. You just have to trust me that when data is stored off-row, there's a pointer, and it points to all the other pages that the lob data is on. We're good on that. We're going to stick to that. Now, if I needed more rows, so how many rows, or how many reads rather, is this going to do? If I'm selecting 10 rows out of post, now there are 10 numbers here, it's the primary key, so it's guaranteed it's only going to be 10 rows. I can put a top 10 in there. All right, we're doing pretty good. All right, so let's run this. Now we'll get in there. And messages, and now 762 logical reads and 22 lob physical reads just to get 10 rows of data out. Now, this sucks, right? Like what no one ever thinks about when they design tables is how big a column should be. Thankfully, the folks at Stack Overflow are pretty smart, and when they designed the post table, they didn't make a horrible mess out of it. There's one big column in there. It's the body column. It's an Envarcar Max. It has the text from every question and answer. Now, you're lucky that I didn't get the post history table involved because that has all the edits in it. That's just a nightmare. But they did a pretty good job designing this table. Bringing back that one column makes our query stink. Now, I find that very distressing. I think the fact that bringing back one extra column can cause hundreds and hundreds of extra reads, I find that distressing. I don't like the way that works. So we're going to have to figure out a way to do this a little bit better. Now, let's go back to Management Studio. Let's scroll down a little bit. I did this on my big monitor, so like the scrolling takes a little bit longer than I'd like. Now, the minimum amount of memory that a query will ever ask for is 1 meg. right? At least on most servers, the default is 1 meg. It's 1024K. It's 1 metric meg. If you want to say it, if you want to get into an argument about 1000 KB, go ahead or jump off a cliff with it. I don't care. So this is the minimum that a query will ask for ever, right? It's every memory that runs is going to say, I want 1 meg of memory. So now I have an interesting question that I'm going to post over in here. And that's, how does SQL Server estimate the size of variable length columns? I'm going to give you all a minute to marinate on that. Full column length, all right, who else has got some stuff? Full column length, that's a popular one. Average length and statistics, ooh, we have some statistics freaks, huh? We got some people who have looked at a histogram. All right,
Too much trust in SQL Server.
Yeah, right, look at this, this is fun. All right, let's go. Let's test this out a little bit. Let's see what happens. Now, if I have a table that looks like this, right? I have an int identity, which is my primary key, which is the only index on the table. I have an order date, which is a date time, and I have a varchar and then varchar column. Now, the sucky thing is, and I almost just said an awful word, is that SQL Server, no matter what data is in the column, no matter what the statistics say about the average length, it will always estimate that half of that column's variable length is taken up by text, or by data rather. Now, the important thing to notice about the queries that I'm going to run is that I'm not sorting by the big columns. I'm not going to say order by varchar column. I'm going to order by the order date column, which just isn't indexed. So let's look at the memory grant, or let's look at what happens when I run these. Now, it's going to be a little bit different, and I should turn on query plans because that's half the point of the damn exercise. If I turn on query plans and I look at these, the select top 49 from this table where I order by order date, that's how many of those, that's how many rows and columns it took for SQL to ask for extra memory on top of that. So we moved up from 1024 to 1056. It took 49 rows to do that. It only takes 28 rows of SQL having to sort the varchar data to ask for the same memory grant. So they both ask for the same one. It just takes different row thresholds to get there. Now again, I'm not ordering by those columns. I'm just ordering by an unindexed column. So SQL has to do all the work to sort it. And what sucks about those memory grants is that the only data in that column is just the letter A. There's no empty spaces. There's no figments of your imagination. There's no GUIDs. There's no ipsum lorem expecto whatever nonsense. There is just the letter A, but SQL Server is estimating that half of those columns are occupied by data. And that's just a nightmare. Now, even if you don't go and say order by at the end of your query, SQL Server might inject sorts into your plans for various reasons. Either it thinks a merge join is a really good idea, it needs to order data for a stream aggregate, or you're using some windowing function where you're just like, oh, I just need to partition by this thing and I'm good. But guess what? SQL Server needs to order data to support different things. So even if you don't explicitly say order by this thing, SQL Server may still need to order data inside a query. And I didn't need to do that. Now, moving down the line a little bit. So how many people have tables that look like this one? Let's get this pasted in here for y'all. Woohoo! All right. I should probably scroll to the table, right? So how many of tables look like this? Where some ding dong just went as just like every column needs to be in varchar because I don't know what the data is going to be. So I'm just gonna, please God, just make the data fit. I'm sick of these string and binary truncation errors. I can't take it anymore. So if I order, again, just by order date, it only takes 7 rows before SQL Server says, I need more memory. So think about it like this. SQL has to do this work to sort the data. It's not sorting by the big data. It's sorting all that data by another column. SQL Server needs to get that data. All of it needs to arrive at the sort operator. It needs to order by the order date, but it needs to rearrange all the other data you're sucking along that query by that order date. So it's not ordering the varchar max column, but it has to order the nvarchar max column by the order date column, and that's what SQL Server needs all that extra memory for. Now, it's not going to ask for all the memory in the world. There are some, algorithms and heuristics and other fancy computer sciencey things inside SQL Server. It'll try to strike a balance between like asking for memory to do stuff, spilling some stuff to disk, trying to like be nice to the hardware that you put your SQL Server on. Now, let's do some experiments with different columns. So we're going to order all of these. We're going to order this stuff, and I had to write the numbers in there because I'm so bad at math that I can't do like the KB to MB math on my own. So if I select the top 1,000 from memory again, and this is the nvarchar 10 column. Let us scroll back up here. This is a 10, 100,000, 4,000 and max. So if I sort the nvarchar 10 column by order date, 1,000 rows, I get an 88 meg memory grant. Now that doesn't seem too bad, but it's only an nvarchar 10. If I go on and I do the nvarchar 100 and I sort that, all of a sudden we're up to, I think it's about 200 megs to do it. If I do the nvarchar 1,000 and I order that, all of a sudden we're up to, what was that? 1,300 megs. So a gig and a half, almost a gig and a half of memory just to sort one column by another column. This is starting to get nasty. If I go and if I try to sort that in nvarchar 4,000, all of a sudden, oops, that was not F5, that was just regular 5. If I do this one, it's almost 5 gigs of memory just to sort this. Like, this isn't SQL doing anything interesting. This is just sorting the data because you asked for it to sort the data. SQL is a dummy. It just does what it tells you. It's a very, very good dog. But it's not a smart dog. Now, if we select the top 1,000 star from this, we get all of these columns back, right? Now, just keep in mind, these are all just the letter A, and we're not ordering by any of these. We're just ordering by order date. We ask for 11 gigs of memory to sort just the letter A across those columns, because SQL Server has no damn idea what's in there. It's not paying attention to anything. The storage engine knows. The storage engine is hip to it. It's like, it's the letter A. I don't have to do anything. The optimist is like, I don't know. It freaks out. It loses its damn mind. Now, this is an example of how SQL Server will ask for memory, even though you didn't. So we don't need a sort to do that. So let's run this. It's going to select the top 1,000 rows, but I'm going to join memory grant to itself, and I'm going to join on order date. Now, the important thing about joining on order date here is that SQL Server doesn't have a join choice really, because order date isn't indexed, which means it's not ordered, which means that the likelihood that it's going to do a merge join is very low. And it also means the likelihood that a nested loops join is efficient is also very low. This is unindexed data, and SQL doesn't know what's really going to happen with it. So if I run this query, joining on order date, I get a whole bunch of stuff back, and in my query plan, I get a hash join. And the hash join is also a memory-consuming operator. So the two most common are going to be sort and hash join or hash match aggregate. Excuse me. Both of those are memory-consuming operators, and both of those require the entire result set arrive at them before anything happens. So sort, all the data has to arrive. It wouldn't make sense for you to start sorting data, get new data, and then say, wait, start over. Move the 2s over there, move the 7s over there, move the 9s. It wouldn't make sense. Same thing with hashing. When all that data arrives, SQL Server has to hash it, make sure the hash is unique, watch out for collisions, this, that, and the other thing, and then it has to, and then it does this. So it needs memory to do that. And the hash tables happen as much as possible in memory. They can spill, but as much as possible, they happen in memory. Now, the memory grant that I have here is huge. I forget what the number is, but it's gigantic. It's 10 gigs of just to do a hash join on order date because I'm dragging all of this useless data around. And again, it's just the letter A. I have nothing interesting. There's nothing going on here. I was too lazy to write a good demo with more data. I just stuck the letter A in every single column. Now, this is just getting us primed up for stuff. Now, I have to scroll past a little bit of this stuff that I decided to skip. Now, what happens here is it makes indexing very, very challenging. Now, how would you index for this query? right? You're selecting everything from the post table. Again, we know the post table is not that wide, but it's pretty wide, and it's got that body column in there, which is an varchar max. It's also got the tags column in there, which is an varchar $150, and a title, which is an varchar $250. So it's got some fairly sizable data. And using what we know now about memory grants, how do we index for that? Like, how do we add an index for this that SQL Server will use and be happy with? Well, we could make a key on owner user ID with no includes, and we could just hope SQL uses it forever and ever. Just no includes, we do some includes, we could do all includes. We just don't know which one is going to make SQL Server happiest. But the optimizer will ask for this index because the optimizer is out of its damn mind. That is the one key column on owner user ID, and that includes every other column in the table. Every other one in the includes. That includes body, that includes title, and that includes tags, which is gigantic amounts of data. Can you imagine sticking the body in the includes here? Like, what would happen when people started asking a lot of questions? It would be a nightmare. So you're staring at this and you're like, I just chose a crappy clustered index. I should have chose owner user ID. It's not unique, but I'll bite the bullet on the not uniqueness, and this will make everyone happy. Now, the optimizer asks for that stuff because, like me, in my demo data, it's very, very lazy. There's a tipping point internally in every single query where SQL will change its mind about how to do stuff. Now, selecting everything from the post table with an index on just owner user ID, there's a certain point where SQL says, oh, I'm going to do a cluster index scan, and then one more row means, oh, well, I'm going to do an index seek and a key lookup because I think this is going to be cheaper. The optimizer doesn't want to make those choices. It just wants to make one choice, give you your data, and be done with it. That's why it asks, and that's why that four-letter word DTA will ask for the craziest indexes imaginable. It'll ask for the most aggressive indexes possible. Like, index everything. Just do it. Come on. Column store something, please. Index views. I need it. Just give me everything. Query optimization has a part of the process called index matching. Now, index matching is a bit like the dating game where the query starts running and it says, my perfect index looks like this. It's like, this is my Prince Charming. And the table is just like, I don't have anything that looks remotely like that. Good luck, query. I get this crap. I have a case of bud. You want it? The query is just like, this point is like, okay, I'll try my chances elsewhere. Now, that's what a missing index request is. It's a cry for help on a really bad date. You don't want to listen to every single missing index request out there, but what you want to do is think of it as like, okay, SQL is clearly telling me that something is wrong here. I could be doing something better. I could be doing something as a DBA that would make SQL Server happy. I don't need to be dealing with this. I don't need SQL Server telling me that I'm missing indexes because I'm a good DBA, and I am in fact not missing indexes. You're lying, SQL Server. This, of course, gets harder with joins. So if I select everything from the post table, I get a different index and I get a different join algorithm than if I select everything from the users table. They're doing the same join and just get the same amount of data is coming back. But when I need no other information from the post table, it will use that narrow index on the post table. And that's pretty cool. Right? So he was like, oh, I'm smart. I'll use a merge join here. Everything's ordered. I can just spit everything together. I'll do my data zipper and shove everything along. It's beautiful the way that works. Now, this is an annoying set of questions here because they all will influence what SQL Server chooses for indexes and for join algorithms. So rather than sit there and make you ponder about it, we're just going to say yes. All of this stuff will influence what SQL Server chooses for indexes and for joins. And I think this is really, really annoying. I just can't get past the fact that like we're in 2017 and everything's in memory and on SSDs, and SQL Server is still costing stuff and thinking about things like we're on hardware where like the disk drive looks like a record player and the CPU can barely can't do two things at once. It's like you have Minesweeper up and you can play Minesweeper, or you can have like Netscape up and like maybe hope a web page downloads this month. It's like the worst combination of crap. Now, there are ways, thankfully, to defer the pain of the clustered index scan, to take away SQL's, to like make SQL reliably choose the indexes that we want it to choose. So this will never be pain-free. At some point, your users want that data. That application that you spent billions of dollars developing has put that data in the database, and gosh darn it, you want it back. How and when you get that data makes a big difference. So you still want to use narrow non-clustered indexes because you still have a fairly narrow set of predicates. You have a pretty common set of predicates that you use to join and filter on. And if you're okay with changing code and experimenting with those index definitions, well, we can do some fun stuff. So this is our query, and I'm gonna head back over to Management Studio because happened again. It's gonna happen every single time. Go away. This is why I hate PowerPoint. I wish, man, if anyone from the Management Studio team is listening, put PowerPoint in Management Studio so I never have to switch windows again. I would love you forever for that, or at least give them like a graphic component. So these are the indexes that I have on posts and users. They have red squiggly lines because IntelliSense is kind of a dummy right here, and I've already created them, so I didn't make you sit through the index creation process. I'm a top-notch presenter. So these are our indexes. There's one on posts. It's on owner user ID, and I stuck the cluster index key in there just so we're all aware that it's there, and it includes post type ID. Over on the users table, we have creation date and reputation and ID. And those are the three key columns in our non-clustered index. And this is our query. So I'm going to put this poll into chat. Hope that people click on the thumbs, because that's my only form of validation at this point. No one's asking questions, so you clicking on the thumbs is all I've got going for me. If I don't see thumb clicks, I might just jump out the window instead. Be a lot of dead air for poor Daniel to deal with. Trying to call the police and figure. Yeah, see. I'm only on the second floor. It won't hurt that bad. I'm fat, I'll bounce. All right, look at those thumbs. Thank God, all you nice people out there. So I want you to be aware, I am using this hint, and that this is a new hint for SQL Server 2016. It's not documented. Don't use it. Don't put it in production. Joe Sachs says it causes stack dumps sometimes. Please don't use it. I'm using it here because I just want this query to go twice as fast. So please.
Now everyone's going to use it.
Yeah, no, everyone's going to use it. Well, everyone would use it if they were on 2016. All these people are on 2008. I want to hear about it. So this is our query, right? We're selecting everything from the users table. We're selecting the ID from the post table. We join users to posts. That's what relational data does. It joins. We join it on owner user ID in the post table equals the ID in the users table. That's the relationship. And we have these predicates on creation date, reputation, and post ID. So let's run this query. Make sure I have that on. We are good to go. We're rocking and rolling. And top-notch presenter today. I got stats, time, and I/O on, and we can see that we did 25,000 or so reads from the post table. We did about 80,000 reads from users, and we spent about 4 seconds of CPU time and 2 seconds of total time running this query, right? So we get 2 seconds to bring all this data back. What's going on in there, right? What's going on there? Did we use our index? I don't think we didn't use our index. We scanned the clustered index on the post table. We have failed miserably as data developers, as database administrators, to get SQL Server to choose our lovingly crafted index. It has not used it. We have scanned the clustered index like a loser. Losers at this point. No coffee. So again, these are our indexes. We're not changing them. I just want the definition there for reference. So what I want to know is, will this query be faster or slower? We're going to hint our index. Right in our from clause here, we have hinted our index. Now, Daniel, is my screen really small for you, or are you just blind? You can be fair.
No, I have 2 monitors actually.
Oh, okay. If I need to zoom, let me know. I can't. No, I don't have no reference. I have no idea how big this looks for everyone else.
I think you're fine.
Woohoo! All right. Well, hopefully everyone else does too. All right. So let me scroll down a little bit, and let's see here. Much faster. A lot of votes for faster. A couple of votes for much slower. Interesting. All right. We get a couple walking optimizers in this room. All right. So let's run this. All right. And let's go. Let's look. See what happens. That was faster than 2 seconds, right? What happened? We did about 75,000 less reads on the users table. We did about the same amount of reads on the post table. Post stayed pretty static. We did so many less reads on users. That's what happened. And that took half a second of CPU time and 125 milliseconds. What gives SQL Server? Now, what I was talking about before with the hash joins, that's here too. So there's our hash join, right? Hash match inner join. And that is because in our indexes, when owner user ID and ID, they are not the leading columns, or it's not the ID column here is not the leading column. So SQL Server kind of has no choice but to do a hash join here, right? Unordered data, not leading key column. SQL Server is just kind of like hash join. So keep that in mind. Join column order and indexes does matter for stuff like that. So what we found is hinting the index in the query gets us this query plan. We do a key lookup from users to get all our information out, and we can kind of see why SQL Server is not asking for a missing index here. Because we look at the output list, right? That's essentially every single column, right? So it's like, oh, well, good luck with that, pal. We'll just do this key lookup and deal with it. This key lookup costs 64% of the plan cost, and that's about 171 query bucks. So why didn't SQL Server choose this plan, which is demonstrably faster? 100 and something milliseconds versus 2 seconds. Why would SQL Server forsake us like this? Why? Let's look at these things back to back. Now, I have about 2 seconds of grace time to breathe here, so I'll do that. And then we'll look at the query plans. Now, we know that in the messages tab, it's going to look about the same, right? 25,000 reads on post, 80,000 on users for the first query, about 2 seconds total. Down here, about 5,000 reads on the users table, about still the same 25,000 reads on the post table, but 105 milliseconds. Why on God's green earth would you choose that other plan? Well, SQL Server is a cheapskate. It is Scrooge McDamn-Duck. When you look at these two queries, and you look at the costs, well, this query costs 154 query bucks, and this query down here costs 266 query bucks. SQL Server, being the miser that it is, chose the wrong plan. It chose a slower plan because it thought it would be more expensive. But by every single metric we looked at, it was cheaper, right? Did less reads, used far less CPU, ran in far less time. Why would SQL Server cost things like that? Well, it goes back to what I was saying before. All of SQL Server's costing algorithms are from like the late 90s. They're not modern. They're not adjusting them for SSDs or more. Like the thing that costs all your queries still thinks that you're topped off at like 3 gigs of RAM with like on a 32-bit 386 just doing nothing. Right? This is what the optimizer is costing things based on. It's not based on modern hardware where, you know, that kind of stuff is fast. It's based on old hardware where like the little arm moving around the disk is slow. That sucks. I mean, I understand why. It's a good point of reference. It's been working pretty well for Microsoft. They make like $1 billion a year on SQL Server licensing. So I get why they're not messing with it. But at the same time, it's like, man, do me a solid here. We're like moving into the age of quantum computing and we're still costing queries like they're on spinning Rust. Now, the key, like we saw, the cost of the key lookup operator was the majority of the hinted plan's cost, right? It was about 64% of it. So that key lookup SQL Server is obviously costing that key lookup very expensively. Now, what we want to happen now, we want SQL Server to reliably choose our narrow index on users. We need to show all that data from users in the app. We don't have a way around it. We can't just go to the developers and say, look, we're not going to show them this stuff. We can't do that. We need to show it. We don't want that key lookup to drag on forever, right? We don't want to add a really wide non-clustered index because then it's going to play the devil with inserts. We don't want to stick everything in there. It'd not be good. How do we make that narrow index a safe option? Like, what can we do? What can we do to tell SQL Server, it would be really cool if you did this here and then did something else later. No one's picking table variables. Thank God. I feel like I've been talking to you. Feel like temp table. Okay, that's not bad. Index view. Geez, you gluttons for punishment. Index views. Don't you read the internet? Oh,
I think all the indexed views are BI people, me included.
yeah, right. Bunch of banana heads. All right, let's go. Let's see what I do. Now I'm going to stop here, and I forget what I'm supposed to do here. Am I go back to the deck? I'll go back to the deck. Let's see what happens. No, nothing in the deck. All right, cool. So I like the CTE option. That's what I'm going to do. I'm going to go with the CTE. Now, what we can do with a common table expression is kind of tell SQL Server, we want to do this stuff over here. And then we can do some other stuff later. And the optimizer will kind of take this as a performance pathway. Now, you could totally do this with a view as well. And you could do this with an inline table valued function. And we'll talk about some other things you can do it with. But we're going to do it with the CTE first, just because it's really easy to show. Most folks are pretty comfortable with common table expression syntax. So what I have up here is a narrow select list, right? I'm only selecting the ID column, which is the primary key of the users table, and the ID of the post table, which is just something I need to show, right? I don't actually need that for anything. I'm still joining my tables together the exact same way. I still have the exact same filtering predicates, right? I still have the 100 there. I still have the post up ID with one there. I still have all the same stuff. Now, what I'm doing is when I'm done filtering data out and just getting the rows that I'm interested in, I join my common table expression back to the users table on that primary key column. So I have a distinct set of user IDs that I can now join back to get all that display level information. And what happens here is things go pretty well, right? A little bit better on elapsed time, a little bit less CPU time. I paid a little bit of a price in reads, about 3,000 more reads, but I'm okay with that. Like, I'm generally okay with that, because what I get from this is some guarantee that SQL Server can reliably and consistently use my narrower indexes efficiently, and then I can just rely on that clustered index for the display level stuff way at the very end. Now, one thing that's important that I want to bring up here, that actually, I'll wait till we get down to this one. So if I face all three off together, oh, not R. So I have the original, I have the hinted query, and I have the rewritten query. I want to talk about a few important things with all of these. Now, first we're going to skip over the messages because we know what's been happening with these all along with the CPU and the reads. We're going to go right into the execution plans. Let me bump that up a little bit for you all. Getting back into top-notch presenter mode. First thing I want to bring up is for the first query, that original query. There was nothing technically wrong with it, right? When we see that index scan on the users table, all of those predicates were sargable. Sargable means that SQL Server, the optimizer, can take those and apply those efficiently to an index. You're not doing anything crazy with functions like I need the substring of the third letter of the month times 4. You're not doing anything weird, right? All those predicates could get pushed down into the index access, and rows could be filtered out at that level. The problem is that you still needed to read 5.2 some odd million rows and filter those out in place. What happens when we use the narrow non-clustered index, we only have to read about 283,000 rows. So really, the big cost and time savings is not having to read 5.2 million rows, actually having to read about 5 million rows fewer or less. Lesser? Fewer? Whatever. You need to do less work on that. The other the thing that I really like about the CTE method is when we do our joins, right? When we do our filtering in place just like before, right? Same filtering, we do our join here. We're not dragging all those output columns along the whole query plan with us. But we're only getting those at the very end. So when we look at the output list of the index seek over here, that's at the very end of the query. That's where all the crap is. So we actually save ourselves a little bit of work, because when we do the index hinted version, which is this middle one, we do that key lookup first. This is like the first thing we do is we seek into the users table. We get all the rows we're interested in. We do a key lookup to get all those rows output. And then we have to move all that crap across the wire until we get to the select. And you can see that SQL Server making a bad judgment on the number and the size of those columns means we got an excessive memory grant. SQL Server asked for a whole ton of memory and barely used any of it. It asked for 1.6 gigs of memory and only used about 7 megs of it, because we got all those columns at the very beginning of the query, and then we had, say it with me, hash match It's a memory-consuming operator. In order to get all that stuff hashed, we needed more memory too, because we needed all those rows to fit or come as close as possible to fitting in memory when that happened. That sucks. It sucks. It's like the worst. Why don't you just agree with me? Why can't you just be agreeable for once? Now, there's some other stuff that's kind of interesting that happens here. Now, one thing that I really dig about the way this works is the nested loops operation it's an awesome optimization called the nested loops prefetch. And that means when every time that thing runs, SQL Server goes and gets extra rows because it knows it's going to need them. But it's like, no, we're just going to get these now because I'm going to need them later, and it just starts shoveling coins in the bag. It's beautiful. So we get that nice optimization from the nested loops as well. That's one thing that I really liked about it. So any questions on this stuff so far? I'm going to assume
No, I don't really see that many questions.
All right. Sweet.
Mostly praise
doing
for your,
really good or really bad.
I think you're doing really good judging by the Slack channel.
Woohoo! All right, and it's early in the morning, so everyone's still drunk from last night. I think that's my main appeal. All right, so there are other ways to take that syntax, and there are other ways to take that syntax and make it work. So you can also use the magic of cross-apply. Now, Adam Mechanic would be extra proud of me for telling you about the cross-apply version. You can do nearly the exact same thing. Now, with the cross-apply, you just take it and flip it. Like you have the CTE is up top, the cross-apply is just flipped down to the bottom. So we're going to take the exact same syntax, put that in a cross-apply, and then we're just going to add one additional predicate to the where clause, where we're joining the ID from the users table up here to the users table in there. And what's really cool is we get the exact same plan, the exact same reads, almost the exact same CPU time. You're going to have to forgive the CPU time. My server is doing other stuff, so it's not just completely set aside for this demo. I mean, compiling important things in the background, Brent. SP Blitzcache is looking great. And the execution plan is exactly the same. So the optimizer is so smart, the optimizer is so wonderful, that it takes that cross-apply plan and it gives you the exact same plan as it did the common table expression plan. The optimizer just goes about. It's really smart. It's a product of like 7 billion grad students at this point. So it's really smart, and it takes both those queries and it rewrites them logically to give you the same execution plan, because functionally they do the exact same thing. Now, of course, you could also, if you just needed to like check the existence of stuff, take that and stick it in exists. And what's really nice is that exists doesn't give you duplicates. So this is actually a little bit quicker, but you get functionally the same plan where you get the two index seeks, they go along. You get one extra hash match aggregate where it takes that ID column and it's like, we're going to hash this a little bit more for you. We're going to take these ints, because what's really nice is when you have an integer and it's not null, the hash is considered perfect. Well, for int, tiny int, small int, and big int, for not null columns, the hash algorithm is considered perfect, meaning you will have no collisions, especially when it's unique. So it's a really nice thing that happens there. So I'm just about done, because I didn't have any crazy encryption or decryption routines. There we go. So how many of you learned something? You can be honest. I'm fine with honesty. Get your thumbs out.
While you're at it, you actually just got a question.
Did I?
I see sometimes plans are showing memory grant and others are not.
Yeah.
My first guess was that there's a difference in estimated and actual query plans, but maybe you have a better answer.
Well, yeah, I don't think you see memory grants in the estimated plans. Let's go and double check here. Let's see, this is the actual plan. This one gets a memory grant of about 70 megs. If we go and we get an estimated plan, I'm going to say no, but I might be wrong. Yeah, you don't see memory grants in there. The other thing is when you run a query, it doesn't always get a memory grant. It might just use the baseline 1 meg of memory. Right? If it just asks for that 1024, it's just SQL's going to be like, oh, whatever. Also, memory grants? No, I don't think the memory grants are in cache plans. If they are, I'll be surprised, because I look for that stuff all the time.
And my countryman Mikael Eriksson says, no time to ask questions. Just typing this made me not hear about 250,000 words from you, Erik.
Yeah, I know. Everyone tells me that I talk really fast, and I agree that I do. but it's because I am so excited about SQL Server. It is a measure of my excitement to be presenting this material to you. If you need me to say, if you repeat anything, slow down, just yell. I'm not psychic. I don't know the rate you people hear at. Oh, keep going. All right, fine. I'll keep going then. All right, so
you were wrapping up, and everyone just tells you to keep going.
Oh, that's fine. Story of my life. All right, so I'm going to skip past all these hidden slides so I don't have to bore you with junk. Brent has this great piece of advice where he says, screen cap all your demos, and then either decide if you want to go through the screen caps or go through the demos. So today I was going through all the screen caps. Sometimes when I present that same thing to clients, I just go through the screens because I don't want to ship demos around. It gets all weird and wonky. All right, so rewriting queries in that way, sort of like engineering your own optimizer routines, shouldn't be your first choice. Like, I really, really do think that when you see queries like that, your first stop should be asking the developers or whoever's in charge if they actually need all those columns, because then if they say yes, you can just start removing them until they complain, which is my go-to gag on that. It's like when Brent changes the SA password. Please don't immediately jump to add very wide indexes. Wide indexes should be an exception to the rule. You shouldn't just go and have like, a billion different copies, because you already chose a clustered index, hopefully. I hope you chose a clustered index on your tables. But then if you go and if every single non-clustered index on the table is like a key column or two and including every single column, you're essentially just remaking the clustered index by every definition except name over and over again. And you don't need that many copies of your data. That's data on takes up space in disk and memory. You start using all these different indexes. All of a sudden, SQL servers get the same copy of the same data over and over again, sitting up in memory. That's no good. It's a waste of memory. I always say disk is cheap and memory is cheap, but use it wisely. Don't murder it. And you can, one thing that I know that I didn't do it here, but please try indexing just some key columns first. See if that makes enough of a difference. Sometimes if that key lookup plan is totally fine long-term because you're not getting that many rows back. So if you just index the key columns that you need for queries, you could totally get away with those key lookup plans. I gripe a lot about key lookups, and I warn you about them in Blitzcache, but it is something that they're not terribly inefficient all the time. If you're not getting like a bajillion rows back, key lookup plan is totally legit. If you're getting like 5, 10, 15, 20,000, even like 100,000 rows, I can live with a key lookup plan. Where I start worrying about it is like when that key lookup is all of a sudden like 97% of the plan cost, and my query runs for 3 minutes because I didn't do a good job of indexing. So if all else fails though, now you have a way to rewrite queries. We'll use your narrow non-clustered indexes and still give you all of those awful display level columns back. Now, when you're doing stuff like this, stuff that we talked about seeing in query plans, stuff that we saw happening when we ran other queries, when we look at the memory grants, the stuff you need to be looked for is the sorts and hashes, because those are memory consuming operations, and those are things that all of your rows have to arrive at. So when you're doing query and index tuning like this, please watch out, be mindful of those operators because they can cause problems. It really helps. In our case, we had the ID column, which was the unique primary key for the table. And so we had a unique column to join everything back on. It really helps if you have one of those. If you don't, you may need to choose a unique set of columns, or either do a distinct or a group by to make sure that you're only passing a unique set of IDs out of your common table expression. Because if you don't, then you can get a lot of weird duplicate data, and you come crying back to me like, this query sucks and the data's wrong and it's your fault. You told us to do it this way. Well, I'm trying to tell you to do it the right way. But you are all nice, brave people, and I assume that you are fine with trying it both at home and on work. And at work, on work. I don't know, I guess it depends on what your job is. It could be on work if you wanted. But anyway, that's all I have. That was my presentation. I hope you enjoyed it. I hope you learned something. I finished early, which is great news for all of you, because now you can go to the bathroom and get lunch and stuff.
So thank you so much. Brent says that I should say thank you for presenting at GroupBy, which goes without saying. Yeah, exactly. So I think he's relying on us two to keep this thing afloat until the next presenter comes in.
Does anyone want to see a picture that I drew a long time ago when I was really sober?
This stuff is going on YouTube.
My wife found this in a bag. I don't know where it came from. It was in a giant Ziploc bag, like in the kitchen cabinet that no one ever looks in. And she was like, "Remember when you drew this?" And I was like, "No." She stuck it in my office and just walked away. And I was like, "All right, thanks." Sleeping on the couch tonight. Were there any questions? Anything that came in? Anything anyone want to bug me about stuff? I'm pretty good at SQL Jeopardy, so if you just have weird questions about things, you can go and ask those too. Nice wall, Ron. I like your wall. JD,
Actually, I learned about, I whet my appetite on nested loops prefetch. So that's something I'm going to read up on.
It's a pretty neat thing.
I think I've seen the hint somewhere when looking at a query plan, but never really understood what it was. George asks, how is the best way to get involved with CTE stuff?
Start writing them.
Yeah. I think everyone who has a SQL blog has written a post on CTEs. I'm just out on a limb here.
I can show you something funny about CTEs if you're interested. Now,
Joseph chimes in. Can you explain the cross-apply syntax versus CTE? If you
sure. So the CTE actually. Well, let me see here. For the common table expression, actually, you know what I'll do? I'll put them right next to each other. So it's a lot easier to see. You guys can still see my screen, right?
Yeah, and this is the reason I wanted to join, because my webcam is using the laptop webcam instead of the Logitech, so I got to figure that out.
Oh, well, weird. So here's the comment. Yeah, that looks cool.
What's that? Oh, my propeller head?
Yeah.
That's why I want to get the other one working. So I've been sitting in my den. So, although I might keep it this way because that looks pretty,
It is. You look futuristic.
Hey, just quick question, Eric. How many screens are you using?
Two.
Okay, because I was wondering how you were switching. Okay. All right. Yeah. I was just wondering how you were switching back between
I'm going to do something dangerous. I'm going to take the webcam and I'm going to show you. That's not toilet paper. That's athletic tape. So I have one monitor going that way, and then the one big monitor going that way.
You have a gigantic monitor. Okay, I don't have a gigantic monitor. All right.
Well, you should get it.
Curved, or is it just the camera?
Oh, it's curved. Yeah.
Oh.
Curved and ribbed and all sorts of weird stuff. I don't know. I bought it came in a Weekend Prince package. I don't know what that means. I don't get it.
All right, I'm gonna see if I can figure out. Oh, webcams. There we go. All right, I'll mute.
So I got asked to explain the CTE versus cross-apply. So the CTE starts up here with with. Keep in mind, if the query prior to this does not end in a semicolon, then you'll run into trouble because with requires. So if I wrote like select one as crap, and then I tried to write a common table expression afterwards, I would get an error, because the CTE requires that the query prior to it be terminated. So I can write this and it'll work. So let's get rid of that. Now, the way the CTE works is you start it with, and then you name your CTE. I name mine pre-check because I'm a big fan of TSA pre-check because I get to walk by all those people standing sweaty at JFK for 45 minutes. And I get to go start drinking early. So I name my table pre-check, and then really the select list is just in here. There's not a whole lot to say about this other than like you have to name, like if you have an expression in here. So like if I did 1 plus 1, I would get an error message until I aliased it as obvious, because all of the columns inside of CTE need to be named. And they also need to be distinct. So if I also did 2 plus 2 as obvious, SQL Server would start getting angry at me because my column name, because obvious was specified twice. So all the column names need to be distinct, and all the columns need to be named. So if you have an expression in there, it has to be aliased as something. The select in here, pretty normal. It goes between a set of parentheses, and then the statement immediately following a common table expression needs to involve that common table expression, whether it's a select, insert, update, or delete. The common table expression has to be referenced immediately following that. You can't like do other stuff and then come back to a CTE. It's not persisted anywhere. It's not like a temp table. It's not a physical structure. Think of it just like an inline view. And then the cross apply is almost the same thing. You'll get the same stuff around aliasing columns or having unique column names, but really it's just a cross apply. It's an open paren and a closed paren. You have to alias the cross apply here, so I need to call it something. I would call all mine CA for cross apply, and then what you typically want to do is inside the cross apply have a where clause that correlates the join columns for the cross apply to the outer table. So here's the user. So here I'm selecting everything from the users table and the post ID from the cross apply. So ca.post ID, and inside the cross apply, the where clause here joins U2, which is the users table, to the table aliased as users up here. That's my wife's arm. She's sick of hearing me talk.
Another way to put it is that everything within the cross apply is executed once for every row above. So for every user, the cross apply runs that query with a nested loop join. So
It can be a hash join too now.
Can it?
Yeah.
Oh.
Yeah.
Cool.
Let's see.
Like a shortcut optimization.
I can show you.
It's my favorite parallelization trick otherwise.
Now, I've seen it mostly with column store, but it's happened with other stuff. So if let's see, select top from users, and you have to forgive the syntax on this one. That's where I don't have SQL prompt installed. So everything looks like Erland Summerskog's blog. Cross apply, select. So it's at least it's not in what's it called, Comic Sans. Select. Let's see here.
I think he writes his entire blog in Times New Roman without formatting.
He does. He's nuts. Let's see here. Users. Select from post. What are you complaining about? Oh, it's all. Oh, that's right. From post where. I'm gonna be slightly fascist about this. P is you. P dot owner user ID user ID and let's see. No, that shows nothing. Actually, you know what? I bet that's why. I bet the top is throwing it off. There we go. Hash join.
Oh.
Took a little fiddling, but you can get a hash join out of it. It'll happen with cross apply sometimes, not just outer apply. But I noticed it when I started using stuff with column store, and it was funny because a long time ago I read I think like one of the formative pieces of literature was like the Paul White's articles on SQL Server Central about cross apply, and I remember reading those, and he said it's always optimized as a nested loops join, and then I saw that when I was using column store for something, I was like, oh, Paul White was wrong 10 years ago now. Yeah.
Upper one of the parallelization, parallelism operators.
I'm sorry, what was it?
Could you check the upper one of the two parallelization?
This one?
No, the right one.
This one?
The repartition. Yes, it's hash.
Yeah.
So that's why then. Because it's usually round robin, and that's what creates the parallelism. So it creates, it's like you're 1, you're 2, you're 3, you're 4, and then those start individual streams from the bottom.
It's funny when you start reading about parallelism, like the different modes that it can operate in, and you're like, why don't you do that for me? It's like round robin, hash, range, like demand, something other. Some other one is like, why can't I just pick which one I want? Because sometimes one's cool. I want to see it happen. But I can show you guys something funny that happens with common table expressions. Now, a lot of people will be under this weird impression that CTEs are persisted somewhere, right? Users, but they're not. And something that everyone should be aware of when they start writing start writing CTE syntax. Okay, you select, oh, come on, keyboard, top one, UD ID. My Mavis Beacon CD is in the mail. Someday I will have the ability to type. Now, if I select, let's see, I'm going to see CTE.star from CTE, join CTE as one on CTE.ID. ID. If I run this, and hopefully it'll work, I'm going to have scanned the users table twice. If I just run this, it's a users table once. If I join it to itself, it re-expands that syntax and does it again. If I join again, CTE as A2 on CTE.ID equals CTE2.ID, I will come up with a third scan of the users table. So every time that syntax needs to be joined into something else, it has to re-expand and rerun that query. There's no way. It's not like Oracle. Oracle is really cool. Oracle has a hint where you can materialize a common table expression, which I think is just dandy. You can't do that yet, if ever. I don't know. Maybe there's a secret trace flag for it that I just don't know.